Good day, ma'am. I am Jeremy P. Valencia, and I am here to report my chosen topics in chapter number 1. So the first topic that I've chosen chapter number 1 is atomic structure.
You're just too good to be true. Can't take my eyes off.
An atom is consist of dense, positively charged nucleus of a large distance by negatively charged electrons. Nucleus consists of substance particles called neutrons that are neutral and protein that are positively charged. Basically, atoms are neutral for the number of protons and electrons that surround the nucleus are the same. Although extremely small, the nucleus still contains eventually all the mass of the atoms. Many organic chemists and biochemists use angstrom to express atomic distances. A specific atom is described by its atomic number that represents the number of protons or electrons in a nucleus. All atoms of an element have the same atomic number. For example, hydrogen has an atomic number of 1, 2 for helium, 3 for lithium, 4 for beryllium, and 5 for boron. But they differ in mass numbers depending on how many neutrons they contain. Atoms containing the same atomic number but different mass number are called isotopes. Relatively, the weight average mass in atomic mass units or AMU of an element's naturally occurring isotopes is called the element's atomic mass or atomic weight. Moreover, in electrons, its behavior can be described as a wave equation. Wave equation is used to describe the motion of waves in a fluid. The solution to a wave equation is a wave function, or orbital, denoted by the Greek letter psi. An orbital can be thought of as defining a region of space around the nucleus where the electron can most likely be found, which basically describes the properties. Aside from this, orbitals also have 4 different kinds and seams. Aside from this, orbitals also have 4 different kinds and shapes. These are S, P, D, and F. The most common of these orbitals are S and P that are usually seen within organic and biological chemistry. The S orbital is spherical with the nucleus at its center, while the P orbital is dumbbell-shaped and can be oriented in space along any of these oriented in space along any of 3 mutually perpendicular directions, arbitrarily denoted px, py, and pz. P orbitals also have 2 parts or commonly known as lobes with the positive and negative signs, which is separated by a region of 0 electron density called a node. Orbitals are organized into different layers around the nucleus of larger size and energy. Different layers or electron shells contain different numbers and kinds of orbitals, and each orbital can be occupied of 2 electrons. As what we can see in the periodic table and any other reliable sources, The first shell contains a single s orbital indicated as 1s, thus holds only 2 electrons. The second shell contains an s orbital indicates 2s, and 3 mutually perpendicular p orbitals, each designated 2p, and this holds a total of 8 electrons. The third shell contains an s orbital indicates 3s, 3p, and 5 3d orbitals for a total of 18 electrons. The 2 electrons in each orbital are represented by up and down arrows. That's all for the topic number 1 that I've chose in chapter number 1. Let's proceed to the topic number 2 that I've chose in chapter number 1, which is atomic structure, electron configurations. In electron configuration, the lowest energy arrangement or ground state electron configuration of an atom is a listing of the orbitals that the atom's electrons occupy. In order to come up to the right sequence of orbitals, they establish 3 rules. The rule number 1 is the orbitals of lowest energy are filled first. This will look like 1s, 2s, 2p, 3s, 3p, and so on. 1s must put in the first shell for it has the lowest energy, followed by the 2s, 2p, 3s, 3p, and so on. Rule number 2. Only 2 electrons can occupy an orbital, and they must be of opposite spin. This spin can have 2 orientations, denoted as up arrow and a down arrow. Rule number 3. If 2 or more empty orbitals of equal energy are available, 1 electron occupies each with the spins parallel until all orbitals are half full. That's all for the topic in chapter 1. Thank you for watching. Keep safe always and God bless.